got the last question to do on the nth of unity. So this comes straight out of the 1996 HSC paper, question 8. So we're going to let omega equal cos of 2 pi r 9 plus I sine of 2 pi r 9. So 3 parts. We need to show that w to the power of k is the solution, where k is an integer. Prove that prove those are equal to -1, and then we need to show the result of cos of pi r 9 times cos of 2 pi r 9 times cos of 4 pi r 9 is equal to 1 over 8. Okay, so part I. Right, so we need to show that w omega k is the solution of z to the power of 9. Take away 1 equals 0. So all we need to do is go omega to the power of 9. Okay, it's going to be cis of 2 pi on 9, or to the power of 9, because we've got omega equals that. So we need omega to the power of k. We're going to show the result for omega to the power of 9 first. Okay, so using De Moivre's theorem, it's going to be cis of 9 times 2 pi on 9. 9's will cancel, so it will be cis of 2 pi. And what's cis of 2 pi? Okay, so what's the cos of 2 pi? Pardon? Nope. 1. Okay, so think about your cos curve. Okay, is 1. And what's sine of 2 pi? 0. Okay, so you need to know your sine and cosine curves. Oops, so it's going to be 1 plus 0, so 1. Okay. So omega is going to be a solution because if we substitute that root in there, but 1 to the power of 9 take away 1, which is 0. Okay, so omega is a solution. Okay, which implies that omega to the power of k, or to the power of 9, okay, swap around those indices. Right, so we know what omega is now because we've just shown it's 1. So omega to the power of 9, is 1. So we've got 1 to the power of k. For any integer k, it's always going to be 1. Okay, 1 to k. Okay, which is 1. And then we substitute back into the solution z to the power of 9, take away 1, 0. Okay. So z omega to k because I replace the z to the power of 9 with omega to the power of k. Then take away 1 and I'll get 0, just like I've got in the equation. Okay, so omega k is the solution, i.e. root, of z to the power of 9, take away 1 is 0. Right, so part 2, we can show that omega to the power of 1 all the way through the omega to the power of 8, add all those and we have -1. Okay, so what to remember from last lesson with this concept? The sum of the roots, yep. Okay, so we know that omega to the power of w. Okay, so we've got omega plus omega squared, omega cubed plus ... Okay, how many roots are we expecting for the polynomial? What's the degree of the polynomial? 9, so we're having 9 roots. Okay, so sum of the roots one at a time. So we've just proved that WK is the solution for any integer k. Alright, so we can set the integers up that way. Alright, to say that those are the solution. And the sum of the roots are sum one at a time. So using my polynomial skills, it's going to be negative b on a. Right, so what's b and a? Okay, a is 1, coefficient of your highest power, and then b, because there's no z to the power of 8, is 0. Right, so this is going to be 0, but w to the power of 9 is 1. Alright, so you're reading the question because it said omega to the power of 1 through to omega to the power of 8 equals negative 1. Right, so all we need to do is move that over to the other side. It becomes a negative 1. Therefore, omega is omega squared, omega cubed, omega 8 is going to equal negative 1. Alright, so hence show that cos of pi r 9 times cos of 2 pi r 9 times cos of 4 pi r 9 is going to be 1 over 8. Right, so I'm going to rewrite these solutions slightly. Okay, so there we're going to have omega plus omega to the power of 8, just rearranging it slightly. Omega is omega to the power of 7, sorry. It's omega squared. Is that right? Yep. Omega squared plus omega to the power of 7. Omega cubed plus omega to the power of 6. Omega to the power of 4 plus omega to the power of 5 is negative 1. Okay, now this needs to be a bit of manipulation here. Remember that we've set this for any integer k. Alright, so I can actually change the powers of here because I know that w to whatever power is going to be a solution. Alright, so if I manipulate it like this, okay, just mainly getting power 1, 2, 3 and 4. So omega plus omega to the negative 1. Okay, so I'm manipulating these index to match what I've got here because I'm going to use a rule next up to manipulate my expression. Okay, they're my roots because I've shown that omega to the power of k is always 1, or is always the solution, sorry. Right, and the reason why I've done that, because I can set omega to the power of k, using De Moivre's theorem as well, it's going to be cis of 2 pi k over 9, using my formula from the start, and omega to the minus k, using De Moivre's theorem again, so cis of negative 2 pi k on 9 because k is negative. Alright, the other result I will need is cos of negative x is equal to cos of x, and sine of negative x equals what? Do you remember? Negative sine of x. Why? That's your cos curve. You can tell me about the cos curve. Mirrors, we'll call even. Tell me about the sine curve. Oh, because of the rotation of 180 degrees. Okay, so that's why we're setting that. Okay, so what we're going to do is for each of these values for k, because I can then go further manipulation, I'm going to go k equals 1, 2, 3 and 4 and add the two k is positive and k is negative for each of those rows. So, w to the k plus w to the negative k. So we had w plus w to the minus 1. Right, so we're k equals 0, 1, 2 and, oh sorry, not 0, 1, start at 1, and 4. So there are 4 values for k there. Okay, so it's going to be cos, does this or cos? Oh, not yet. Okay, cos of 2 pi over k, 2 pi k over 9 plus I sine of 2 pi. Show you my Delmoser sound there. Modulus 1. We've already shown it. Plus w to negative k, so it becomes a cos of negative 2 pi k over 9 plus I sine of negative 2 pi k over 9. Okay, so going back to your odd and even function that we set on the side, that means cos of negative 2 pi k on 9 is going to be the same as the positive equivalent, and I sine of negative 2 pi k on 9 is going to be negative I sine of 2 pi k on 9. Okay, these two will stay the same. Okay, what this is allowed to do is allow me to do a subtraction and eliminate two of the terms there. Right, so we'll go back and label this one 1. Right, so what I've just got number 2, I'm going to put it to number 1. So w to k plus w to negative k, it can equal 2 cos of 2 pi k on 9. Okay, so we don't actually need to do this bit yet because we're now putting it into the result. Alright, so what we need to do, go back to equation 1. So, k is 1, k is 2, k is 3, and k is 4. So it'll be 2 cos of 2 pi on 9, 2 cos of 4 pi on 9, 2 cos of 6 pi on 9, and 2 cos of 8 pi on 9. Substituting for k.
Yep. 8 to 2 to 7 and then to negative 1.
Because I proved, show that w to k is going to be a solution. Okay, by doing a generic w to k after I've done w to 9. Right, so that means whatever value for integer I have in place of k, for that, it would also be a solution for that root.
So you're
Okay, because-
disregarding everything else.
So,
And you just thrown everything else out, like, away.
no, I'm using it to...
Yeah, but what happened to all the other powers?
I've manipulated these powers. I've shown this result here using what they wanted me to use for the powers. Okay, but to do this next bit, it will hopefully make sense at the end. I'm manipulating powers by doing some skills in mathematics rather than doing this 8 times for W to K. So cis of 2 pi r 9, cis of 4 pi r 9 all the way through. Instead of doing that, I'm just matching it into this because I know that K can be any integer. Okay, so if I can do this and use this technique, realising that there's a pattern, okay, that's why I'm showing you these styles of question, I can have 4 things here rather than have to work with 8 things over here. So, put it into equation 1, we're going to get 2 cos of 2 pi on 9. That's when the k was 1, when you had the wk plus w to the negative k. Sorry, w to 1. Alright, and I've shown that instead of going 2 cos of 2 pi on 9 plus, sorry, cos of 2 pi on 9 plus I sine of 2 pi on 9, and then have cos of negative 2 pi on 9 plus I sine of negative 2 pi on 9, I'm just going to have a lot of terms there. Okay, so I can use this because I know that k is going to be match any integer I want it to set, then I can make this work. Alright, plus 2 cos of 4 pi on 9, that's k is 2. Okay, so put in 2 here. Plus 2 cos of 6 pi on 9. That's now k is 3. And then you have the k to the 4, so w to the 4 plus w to the negative 4. And simplifying using that result is going to be 2 cos of 8 pi on 9. Okay, and all that equals negative 1, what we got from part 2. Okay, number 3. Alright, so some further manipulation. How are you supposed to know this? Don't know, just got to know what you're doing, I guess. I'm showing you because these are the styles of questions they asked you in your HSC. So, cos of x plus y, okay, using extension 1 trig. Okay, so cos of x cos y, sorry, take away, sine of x sine of y, and cos of x take away y, going to be cos of x cos of y plus sine of x sine of y. Yeah, that's what up to 4 and 5. Okay, so what we're going to do is add them. Right, to eliminate the sin x sin y bit. So cos of x plus y plus cos of x take away y is going to equal 2 cos x cos y. Okay, so some further manipulation that we need to do. Okay, it's going to let x is the sum of capital A and capital B on 2, so I'm setting 2 new variables because I'm going to try and link it back to what I've already got up here. Alright, and hopefully you'll see this in a moment. Y is going to be A take away B on 2. So equals 2 cos x, which is A plus B over 2, cos my A take away B on 2. So just splitting x's and y's here. Right, what's x plus y? Using the... Yep. A over 2 plus B over 2 plus A over 2 take away B over 2. Alright. So that means cos capital A plus, what's x take away y? Well, technically negative B. Yeah, 2b over 2, which is just b. Okay. Not technically 2, negative, sorry. Okay. So the reason why I've set this up, because I want to get the addition into a multiplication. Because the question, you're multiplying 3 causes together. Okay, that's why I've had to set it up into some form of multiplication using some manipulation skills. Okay, so we're going to grab this, then this in there. I'm going to plug it in here. So A is going to be 2 pi 9, B is going to be 4 pi 9, and use that result over there. Okay, to hopefully get something closer to what I'm trying to prove.
So to do that, you've just made your own little formula thing.
Well, yes, you the results already know. Okay, this is an actual HSC question out of the 1996. So these are the questions you will come across in your exam. All right. One question of your whole exam, but I'm just letting you be aware of what's in the exam. That's why I'm going through a question where we may not sit down and necessarily be able to work it out, but at least I can show you, you'll get an idea of what sort of things you need to do. Right, so noting here we've already got the 2. Okay, this doesn't take care of that. So if I double 2 and 2, okay, so multiply both sides by 2, then this is going to be 4. Alright. So 2 is going to be 2 times all that. Alright, so that's number, what are we up to? 6. Put that into number 3. Right, so A is going to be 2 pi 9, B is going to be 4 pi 9. So it's going to equal 4 cos the sum of these two roots, then going to halve it, A plus B over 2. So we get 6 pi on 9 when we add them, then we're going to divide by 2. Okay, so we're going to 4, do it cis or cos in sines? Oh no, we don't need cis. Right, 4 cos of pi on 3. Because 2 pi on 9 plus 4 pi on 9 is 6 pi on 9. And then divide by 2, so 6 pi on 18. Simplify down to pi on 3. Right, so now we need to do this side, we need to now do the subtraction. Okay, so 2 pi on 9 take away 4 pi on 9. becomes a negative 2 pi on 9, and then we need to divide by 2. Okay, then I've got the addition in the middle there, because I'm going to do the same thing for those two terms. There. So it's going to be 4. Sum the arguments. So 6 plus 8 is 14. So 14 pi on 9, and then we have to divide by 2. Okay, so it would be 14 pi over 18 pi. This would be 4 cos of 7 pi on 9. And then cos, we have to do the subtraction. So 6 take away 8, which is negative 2, so becomes a negative 2 pi on 9 when you do the subtraction, and then divide by 2. So we have negative pi on 9 equals negative 1. Okay, remember cos of negative x is the same as cos of x. Okay, so let's just write that. Okay, I'm almost there, still got one addition there. Okay, so I can factorise out the pi on 9 and the 4. Okay, so I'm going to rewrite this as cos of pi on 9, rewrite this to match the same denominator. Okay, because I'm going to use that rule again, because I've got 2 addition, and once I do that, I'll have then 3 things I'm multiplying. I think the whole question was 7, including what we did at the start. From memory, it was 7. Hey? Yeah, I'm thinking 1 and 1 possibly for the first 2, and then a good 5 marks for this, probably. 4 or 5 marks for this. You probably need it, yeah. Okay, so got to use that rule again. However, we don't have that 2 out the front. Okay, so we're just using this, and we're just using 2 here. Okay, the only reason we use 2's here, because in our formula, we had, 2's out the front of each of those. I could probably really factorise that out at the start. Okay, so we're using that rule. So we're going to come cos of A plus cos of B, so that's A and that's B. We're going to use that result. So 2 cos of the sum of the argument divided by 2. So we've got 10 pi on 9. Divided by 2 becomes 5 pi on 9. Cos, and then we have to do a difference. So 3 take away 7, which is negative 4. Negative 4 pi on 9 divided by 2. So it becomes a negative 2 pi on 9. Okay, almost done. Okay, so bring this 2 out again. Right. So remember the result was 1 over 8, so I can bring the 8 down to the other side. It becomes negative 1 on 8 at the moment, all right, because there's still something else I need to take care of. But going back to the question, we need cos of pi on 9, I've got that. Okay, cos 2 pi on 9, I've got that. But I've got a cos of 5 pi on 9. I need cos of 4 pi on 9. Okay? Hey? Well, we would not be preparing you properly if I didn't show you these styles of questions I can ask you. Okay, so 4 pi on 9 and 5 pi on 9. Okay, so I need to change this 5 pi on 9 somehow to get to a 4 pi on 9. Okay, so help me out. What is pi is 180? 180 divided by 9? 20. 4 times 20? Okay, 80 degrees. So pi on 9 is 20. What's 5 times 20? Okay. It took me a little while as well. Okay. So, do you notice anything?
No. They're both, no, I don't know.
They're both 10 degrees on either side of 90. Correct?
Oh,
Yeah? So if you think about your graph,
it's cos 2, makes sense. Because it is
yeah. Alright, so, where's 90?
in the middle.
This one here.
That makes sense. Wowsy.
So, cos of 4 pi on 9, you're going to have that positive value there, is going to be equivalent to the negative cos of 5 pi on 9. Yeah. So equals negative cos of 4 pi on 9. Now this is different from the cos of negative x equals cos of x because of the angle. Alright, we are just changing the y value here. And now remember, cos of a negative angle is equivalent to cos of the positive absolute value. Equals -1, and fantastic, the minuses cancel, bring the 8 down, done. So therefore, cos of 2 pi on 9 cos 4 pi on 9 is equal to 1 over 8. Okay, so this was question 8 of the 1996, equivalent of 10 questions evenly. So when you get up to the last 3 questions, that's where the work can get more sort of in process of what you need to do. Okay? Question?